Hi, welcome back to the session. So in this session, I'll be discussing about the few programs in Lex. So the first program would be the program to count the number of vowels and consonants in a given string. So for this problem, we will be having a Lex program to find out the count of vowels and the consonants in a given text. So let us start with the program. We have definition section, rule section, and user subroutine section in Lex program. So when I was explaining about the structure of Lex program, I was giving you the input saying that there are three sections in Lex program: definition, rules, and user subroutine section. So in the definition section, if you see, so there is a from variable declaration. For the variable B and C, B meant for vowel and C meant for consonants. Since we need to count the number of vowels and consonants, so we declare two variables in the definition section. Coming to the rules part, we have the pattern, and in the user subroutine section, there is a call for YYLX, and finally the vowels and consonant counts will be displayed. So after completing the process, the result will be displayed by using the printf statement that is there in the printf statement after YYLX. So in the rules part, we have the pattern, the vowels, and consonants. So the vowels are given in the small case and also given in the uppercase. If the input falls or in the input matches with this pattern, then the corresponding action would be incrementing the vowel count. So V is a variable which is declared in the definition section, and it is initialized with 0. When there is a vowel in the text, then the vowel count will be incremented by 1. So that's where the post increment operator is used. So if you look at the pattern, we have the vowels A, E, I, O, U in a small case and capital letter. And coming to this next pattern, A to Z and a capital A to Z. So herein, the input falling under the category or the input is in the range of A to Z or a capital A to Z, then the consonant count will be incremented. Now, if you look at the second pattern which consisting of vowels and consonants, but it has the in the action part, it has the count for consonant that it has been incremented. But how it happens? How it possible, like A to Z, which includes both consonant and vowels, but only the we are incrementing the count for consonants, and the vowel count should not be incremented. So how it is taking? So if you give the input for the program, when you run the program, as I have already told you that lex command is used to create the lex.yy.c, and cc is a compiler which is to be called, which is to compile the C program, and -ll which is used to link the lex library. Then after compilation, the program has to be executed, for which we call the a.out file. So a.out, this is a statement to be given, the command which needs to be given in the command prompt. All these commands should be given in the command prompt, and the input is given, and accordingly the count will be displayed. So when the input is given, say for example, the input is given as New Horizon College. So when the first character n is being read, when the first character n is being read by the program, what happens? This n will not fall under the first pattern because n is not a vowel. So the first pattern cannot match the input. So if it is not matched, the unmatched pattern will go to the next pattern. The unmatched text will go to the next pattern. So that is the input. So when it goes to the next pattern, wherein we have the character class, in which the regular expression is given as A to Z, capital A to Z. So definitely that capital N, which is coming under the character class A to Z, capital A to Z. So the count for the consonant will be incremented one by one. So for the character, for the input N, the count will become 1 now. Now, when it reads the next character E, what happens here? It will be matched with the first one. So automatically the vowel count will be incremented by 1. Now, once the input is matched with the pattern, then unmatched input only will be given to the next pattern. So E is matched. So what happens? E will not go to the next pattern. So whatever the remaining unmatched pattern, that will be, the input that will be given to the pattern. So that is the reason, though we are giving A to Z and capital A to Z, it is not counting for vowels. It is only counting for the consonant. Whereas now, if the same pattern, if it is given in the reverse order, first pattern would be A to Z and capital A to Z. The second pattern is for the vowels A, E, I, O, U and capital A, E, I, O, U. If you interchange these two patterns, then what will happen is all the count will go to C, not for the vowels. Though you have the input for vowels in the text, so the vowel count will not get incremented. The reason is, when the first pattern is given as A to Z and capital A to Z, what happens there is, it will be accepting all the input. So when New Horizon College is given, so that each by character it will be accepted by the pattern, and unmatched pattern only will go to the next. But here all the patterns will be, all the input will be matched by the A to Z, so that the character consonant counts will be full. That is, whatever the number of characters comes into the text, the entire character count will be there. Whereas in vowel, 0 will be as it is. It won't change. So initially we assign a 0 for a vowel, so that will be remaining as it is. So this is the one thing which we should understand here. So when you are keeping the pattern, you should be very careful where it has to be placed and what was the pattern before to that, previous to that, that also to be noticed. This program is meant for counting the number of vowels and consonants. So when the output is displayed, it will be displaying the vowel count and consonant count. So this is one simple example program using Lex tool. Hope this program already we have discussed in the previous session. And let me go to some other program. So let us have this program. So herein we see that the program is to count number of positive and negative integers. Similarly, positive and negative fractions. So if you look at this program, we have again the definition section, rule section, and main function we have. In the definition section, there are 4 variables. Why we have 4 variables over here is positive integer, that is PA, negative integer, that is NI, positive fraction, then we have negative fraction NF. So in order to find the count of integers and fraction, and we have the positive number and as well as negative numbers. If the integer is given, so that can be positive number or the negative number. If the fraction is given, that can be either a positive or the negative number. So we would like to count each individual positive integers, negative integers, positive fractions and negative fractions. That's why we have 4 variables that is declared in the definition section and also initialized with 0. Now, moving to the rule section. So in the rule section, the first pattern is 0 to 9 plus. So why the plus symbol is given? The plus is a meta character. What is the reason why we are giving plus symbol is, if you give the number as 12 or 100, and this has to be considered as a single integer. So when you have 12, it should not be considered as a 2 integers. Instead, it has to be considered as a 1 integer. So the reason behind the plus is, when you have the integers, it may have 1 or more digits. So when you have 1 or more occurrence of the digits, so that everything should be considered as a single integer. That's why we keep plus symbol with the pattern. So 0 to 9 is the pattern which is given in the character class. Within square bracket, whatever comes, that will be matched with the input. So we have the range from 0 to 9. So any number which falls under the category of the range of 0 to 9, then that will be matched. And it might be 1 or more digits also. So if it is 1 or more digits also, it is considered as a 1 single integer. So if so, then the PA count, that is positive integer count, will be incremented. So the PA count will be incremented by 1. And the second pattern, we have before the integer, we have the minus symbol. Before the integer, we have the minus symbol. So when you have the minus symbol, so what will happen? So before the integer, if the minus occurs, then it is coming under the category of negative integer. So that's what. So the same way how we are checking for the integer, same way we'll be checking for the negative value of integer also. Now the next one is, if you have fractions, let us say if you are having the fractions like 0.23, 0.23. So that decimal point 23 is also the fraction. It is considered as a fraction. Or if you have 0.23, that is also considered as a fraction. So in such case, so before the decimal point, there might be some integer, or it may not be there also. Maybe or may not be. So if it is there or not, then also it has to be considered as a fraction. So what you do here is, the decimal point has to be kept to match with the input, because in the fractional number you have the decimal point. But if you keep the decimal point simply in the pattern, as you know already, in the rules part, when you keep a pattern like dot, when you have the pattern dot that represent a single character, that represent single character. So when you keep dot, it will be matching with the single character, not the decimal point, because dot is a meta character, so it has some special meaning. So in order to get the original meaning, so what we are supposed to do, in order to obtain the original meaning of meta character, we have to keep the backslash in front of that. So that is why if you look at the pattern, we have backslash followed by the backslash, we have dot. Now, so when you have backslash dot, that actually represent decimal. So in your input, if you have a decimal, then that will be a decimal point that will be matched with the pattern. And before this dot, we have 0 to 9 within square bracket, and we have the asterisk symbol over there. So if you have the asterisk symbol, normally meant for multiplication, so similar to plus, we can use the asterisk as meta character. When asterisk is used, what is the purpose of asterisk is, which I have already told you, that before the decimal, there might be some integer or there may not be also. If it is not there also, then it needs to be considered as a fractional number. Dot 23 is a fraction number. 0.23 also fractional number. 1.23 also fractional number. So in all these cases, it has to accept. So what we supposed to do is, if that number is empty or there is a occurrence of that number, then we have to match. So 0 to 9, that represent the integer part, digits. From 0 up to 9, any digits can be there. And asterisk we have. So asterisk denotes 0 or more occurrence of the preceding character. So what is the preceding character here? The preceding character is some digits. It may be 0 or it may be 1 or it may be 8. So what we do here, we need to keep the asterisk so that if there is an empty string or there is a one occurrence of the digit, it will be accepted. That's the purpose why we are keeping like this. Then after decimal point, we have the fractional numbers, that is falling under 0 to 9 plus. So there should be definitely after a decimal point, then there should be some number we have to have. So that will fall under the category of positive fraction. Same way for the negative fraction, only the minus symbol will be before the number. The decimal point number, I mean fraction number, before the fractional point number, we have the minus symbol. So these four different pattern is used to accept the positive integer, negative integer, positive fraction, and negative fraction. So this is what exactly we have here. Now let us go to the main function. So the main function will be displaying once the process is done. After the process, the each individual variable will be displayed. The value of the variable will be displayed. So value of number of positive integer, count of negative integer, count of positive fraction, and similarly count of negative fraction. So in this, if you take the value here, if you consider the value 12, 23, minus 12, minus 13, 12.12, 13.12 like this. So we'll be having the we'll be checking the values with the corresponding patterns. So 12, obviously it goes to the first pattern. When you have the minus 12, then it falls under the negative integer. Then when you have the fraction numbers, then positive fraction numbers without any sign, that is symbol, then it falls under the positive fraction. The other one would be negative fraction. So in this way, we'll be able to get the values for each and everything. So this is how it is exactly being used. Let me go to the another example. This is one more example we have. So in this example, what we are seeing is here we are seeing the program for counting the number of scanf and printf statement and replacing them with readup and write-up. So scanf and printf statement you could find from the C program. In C program, we used to have the scanf and the printf statement. So in order to find how many scanf statements are there, how many printf statements are there, if you want to know, then this program will be helpful to count the scanf and printf. And suppose if you would like to replace scanf with the readup and printf with writef, means that is also possible. So that's how the program is. Now we'll be having the structure of the program. In the definition section, we have two variable. One is p and another one is yes. To count the printf statement and scanf statement. And we have the rules part. In the rule section, we use the pattern, that is printf and scanf. So wherever you find printf, wherever you find scanf, then the corresponding count should be incremented. So that's why if you look at the count p and s, that will be incremented by 1. Now let me go to the main function. What are the changes we have in the main function? We will look at. So by seeing the main function, you can make out one thing, that we are not passing the input at the time of execution from the user. Instead, we take the input from the file. So we use command line arguments to pass the file name. So we pass the file name and the data is taken from the file. Say for example, we have a C programming file. That file will be passed and we will be taking the file as an input and we do process. Here, when you give the input, what we are supposed to do is we have to pass two files. Why we have to pass two files is, one is the input file and another file is the output file. Why it is required? Because in place of scanf and printf, we need to replace with readup and writef. So we want to create a new file. We want to write a new file in which wherever the scanf comes, the readup should be there. Whenever the printfs come, then there it has to be written with writef. That is why we need to pass two files. One is the input file and another file is the output file. So if you look at the main function, if argument C is greater than 2, so argument C is greater than 2, which means we have to pass 2 files. So totally the argument count will be 3. That is why if it is greater than true, then only the if condition is true, then it will go inside the if condition. So in the beginning of the if statement, file pointer is created, so that we'll be assigning the files to the file pointer. So we use the file pointer variable, and we check the variable also whether it exists or not. So in order to open the input file, the file should be exist. That's why we are checking. If not F1, then it is an invalid file name. Then we should come out of the program. Else it will go to the next statement where the F1 is equal to fopen arg vector, argument vector of 1, which has to be open in the read mode. Same way, the other file which has to be open in the write mode. Now we have the statement in is equal to F1. This I have shown you already when we were discussing some program, the word counting program, where in order to pass the file, the in should be assigned with the file name. So the input will be taken from the file instead of the standard input. Similarly, there is a out. Instead of writing into the output device, standard output, we have to write in the file. So where to be written? It has to be written to the file F2. So for which we use the out. Now we call the YYLX. So when the YYLX is called, automatically it comes to here. It comes to here, the pattern. So if there is a printf statement, it will be writing. So normally while writing the into the file, we use fprintf. So which file we are writing, that is out. What we are writing, writer. So in place of printf, writer will be written. Similarly, in place of scanf, then readf will be written. So this has to be done whenever there is a match for printf and there is a match for scanf. And automatically the printf and the scanf count will be getting increased. So when you run the program, while executing the program, so you have to pass the files. So this is the file, input file, scanf and printf. While executing the program, so you are passing the two files. One is the input file and other one is the output file. So output file need not be created. By default, it will be created. Whereas the input file should be there. So you should have created the file and you have to pass the input for the file. So we have the content of the file, scanf, printf is there. So wherever the scanf and printf is there, respectively, it will be changed in the new file. It won't disturb the original file. The changes will be made in the new file only. So when you pass the two parameters, obviously the if statement will be satisfied and it goes inside. Suppose any one file is missed, then it will come to the else part. Then it will say that it is not part of the it is not matching with the if statement. It is not satisfying the condition of if statement, and it will be saying insufficient argument. So you are supposed to pass two arguments whenever there is a command line arguments. So based on the program, how many arguments to be passed, and it has to be checked. So even in the other programs, when I was discussing about, I was telling you that the program the file, how many files to be passed, so that count should be there. So for that we use the argument count. So there are two arguments will be used. One is argument count and argument vector. Argument count gives you number of arguments you are passing. So if you are passing two arguments, then it will be 3, including the file name. And if you look at the first file, we have mentioned as argument vector 1. So argument vector 0 is nothing but the a.out file. So argument vector 2, that will be the second file. So argument vector 1 will be first file, argument vector 2 will be the second file. So in this way it will be doing the operation. So this is how it does. So this will be changed like this. So with this, we'll be ending the session.